All right, this is the Geometry Unit 4 or Pro Unit 3 study guide or review video. The vast majority of this unit test is vocabulary. So I've put, and when I say that, I mean like 70% of the test is vocabulary. So you need to spend time studying the vocabulary that I've listed here at the top of the study guide. So all of that information is in previous unit lesson videos and in the notes. So you need to do this. You can also Google things. If you don't know what a regular polygon and irregular polygon is, Google it. But all of these items here on the list are fair game on the test, so be aware of that. So all of these need to be studied. So just make sure you study the vocabulary. It's like going to say that one more time. Study the vocabulary. It's the vast majority of the test material. Also, watch the videos over coordinate proof. The coordinate proofs are going to be one of the components of the test as well. Very straightforward, though. You're not going to be doing any of the logical part yourself. You're just going to be basically connecting the dots and putting the actual lengths of the different parts of a coordinate proof and answering for that. So pretty easy, but just make sure you're familiar with the videos for those. I'm going to come back to the regular polygon stuff there and talk about these theorems and corollaries that you need to know. So these are all about isosceles and equilateral triangles. So I'm just going to run through each one. You need to know how to identify these diagrams. I've actually given you the diagrams. So the key thing here is that there is something in bold on these diagrams. So like here, these sides are bold. These angles are not. So here, this would be the isosceles triangle theorem, which says that if you have two congruent sides, then it tells you that the angles are also congruent to one another. All right. All right. Okay, get this to go away. All right. Not sure why that will not go away, but we'll try again here. All right. So then we have the converse of the isosceles triangle theorem, which says that if the angles are the same, then the sides are also congruent. So again, it's saying that when you have congruent angles, they tell you that the sides are congruent. So it's the converse, because with converse, it's the opposite. So if isosceles triangle theorem says that congruent sides give us congruent angles, then the converse will say congruent angles give us congruent sides. So I've written that here as well. Then we have the corollary, which is just taking that information about isosceles triangles and applying it to equilateral triangles. And it basically says that when a triangle is equilateral, it is also equiangular. Pretty straightforward. And then the corollary of the converse says that if the angles are congruent, in other words, if this is an equiangular triangle, it is also an equilateral triangle. So that's pretty straightforward. So you need to just review all of those theorems. You need to review everything you see in the vocab list. And then the one thing you actually have to do in terms of math is calculate the values of these different things to do with polygons. So I'm going to work through this. So we'll do these. We'll do each of these. We'll call this number 1, number 2, number 3, number 4. All right. So for the first one, find the sum of the interior angles. First thing you need to know is what is the n value. In other words, how many sides are there in this figure? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. So I'm going to use n equals 8. I will provide these formulas on a separate file for you, but for now, the formula for the sum of the interior angles is n minus 2 times 180. And so in this case, 8 minus 2 times 180, which makes 6 times 180. And 6 times 180 is 1,080 degrees. And so that is the total measure of all of these angles. All right. So the next formula is for finding the individual angle. Now I'm going to write the formula, but we don't really need to do all the work again because you'll see the formula is basically the same formula we just used, but divided by n. So we need to take the answer we got for n, or for the angles, and divide it by 8 because we have 8 sides. And so when we do that, let's run over here and do 1,080 divided by 8, and we get 135 degrees. So that would be the measure of one interior angle. That's number 2. Number 3, again, uses the answer from the previous one. For exterior angles, you have to do 180 minus the interior angle. So for ours, it means that the exterior angle is equal to 180 minus 135, which equals 45 degrees. That's the measure of an interior angle of that polygon, or exterior angle. And the exterior angle, if you remember, is the measure of this angle out here. So we know where the interior angles are. Those are in the dark purple, and the pink would show us a picture of what the exterior angle would be referring to. And then lastly, we have the formula for diagonals, which is n squared minus 3n divided by 2. Again, that's the formula for D, or the diagonals. So we're going to go through here. We're going to plug in all the values for n in each spot. So we have 8 squared minus 3 times 8 divided by 2. 8 squared is 64. 3 times 8 is 24. Again, all divided by 2. 64 minus 24 is 40. And so we get 20 diagonals. So that's just another example. In the lesson video, I do at least 2 examples of these. So go watch that if you need to see more. But that's really it. So just to kind of review, make sure you look over the vocabulary here. Most important component. Look over the coordinate proofs. If I haven't posted the practice test proof, I will post that immediately after this video. I did examples of those, and then we went over our isosceles triangle theorems. And that is it. Please reach out to me if you have questions. Other than that, it's the end of our review video.